So I just wanted to go into more detail about how I structured the backend of my project. So I did end up using Kubernetes and tried to kind of create a microservice architecture. And so this is kind of like a rough diagram of how it looks like. And so you can see that the outer is a cluster, like a Kubernetes cluster. Inside we have one node, and all of the pods will be inside of this one node. And so in here we have two services. We have order service and an inventory service. They're both implemented in .NET. And so essentially the order service is responsible for taking in the orders. So whenever we go on the Amazon website and we create an order, that kind of payload will be sent to order service. And we also have an inventory service, and this is basically just a list, has details about every product and how many how much in stock do we have of each product. And essentially this one is called in the beginning to kind of list out all of the products here. You can see there is quite a bit of kind of mock data that I have here. And when order service is called, it basically inputs basically a message to the message broker, which is RabbitMQ. So with this message queue, inventory essentially listens on to this queue, and then it will take that message, and it will update the inventory based on what that order was. Both of these services have their own database. The inventory services database is on a Docker container, but the order service has a database also, but I decided to just use an in-memory one because I thought it wasn't really necessary to spin up an entire Docker container just for the order service. Perhaps in the future, if I need one, I can also spin up another Docker container just for that. And this container has a persistence claim to the operating system, which means that if this container does end up even going down, the data will be persisted because it's persisted on the operating system, which is basically my computer. And so if you look outside here, there's a node port and there's also a load balancer. Well, this is the port, this is the actual load balancer here. And the node port is basically a service, Kubernetes service, which allows direct access to some of the services, which is this one. This is kind of good for development, but it isn't really recommended for production because it can introduce security vulnerabilities. That's why we have the load balancer, and I can kind of get into that right now. So I have a separate folder for all of the Kubernetes files here. So I guess I can go into the node port first. So this is a service, a YAML file for Kubernetes service, and it's a type of node port. And I can demonstrate some of these because I do have them running. And so if I go to Thunderport and so node port. So if I kind of run this here, it will basically return all of the data. And so this is on the local host, right? And so if I go back, we can also look at the load balancer. So the load balancer is using Ingress. And so I don't think it specifies a Docker container here because I ended up using just downloading a Docker container directly from their website. And then here it basically specifies where we're kind of forwarding the endpoints. So it kind of exposes the product service and the order service, and it basically specifies the name of that deployment. So even if I go kubectl get deployments, yeah, so this is the inventory service and this is the order service. Oh, it's actually specifying the service and not the deployment itself, right? So if I go I'm forgetting what the command was. Kubernetes get services. Oh, okay, there we are. Yeah, so right here is the inventory service. And then we also have the order service right there. And that is using the, yeah, it's specifying the cluster IP. So if I go into the deployment of the inventory, so this is specifying the inventory service, and here is going to be the container that I deployed to Docker Hub. So if I go to Docker Hub, yeah, so I have to basically deploy the images for both of these containers, and then whenever this container is being deployed, it will, just pull from my Docker Hub. And then here we're also deploying the service so that it can expose the API. And this will expose it to the cluster only, and doesn't expose to outside of the cluster. And so in that way, the load balancer can kind of internally access it. I can go into the SQL servers too here. So here is the SQL server. The image is going to be a Microsoft server. You have to kind of specify all of the passwords and configurations. And this is where the mount is on my operating system. So it basically makes a persistence claim. So that it can persist the data even if you restart the Docker container. And then we have some services for the load balancer and the cluster IP so that it can actually communicate and get data from the API. And I also wanted to get into RabbitMQ. So we're using this image right here. And then there's two ports, one for management and one for, actual, the messages itself. And it also has a service to kind of, expose the API. And so I can actually give a demonstration of RabbitMQ working, but before I do that, I can also show some of the code. So this is the order service. So here I basically have, just a class that implements, like actually using the RabbitMQ client here. So we're configuring in the constructor, and then here we're actually sending the message, which is right here. Here it is using that channel that we configured in the constructor, and we're publishing a message, which is right here, and that is going to be the message that we encrypt. So we are actually sending a message on a channel, and then in the inventory service, which is the other .NET project that I have, we are actually have another class which uses RabbitMQ, and we're basically initializing here, and then yeah, okay, so basically what we're doing is this right here is a background service, because we are actually implementing a class called background service, and this is a Microsoft extension hosting package which you have to implement, and one of the methods that you have to implement is execute async, and so once that is executed, then we are able to listen onto the consumer, which we instantiate in the with the configuration of the channel. And so basically this is an event, so it's an event handler, and this lambda will trigger once a message has been passed into the queue. And so I guess we can just do a quick demo here. So again, let's just say we want to buy something. So we want to buy this watch, 6 of these, add to the cart, proceed to checkout, and then place order. And then if I go to RabbitMQ port, it will basically show how much throughput we have in the channel, and it shows publish and publisher confirmed, and so this will basically show you in real time how many messages are going through on our channel. And I think we can even see some output maybe on our Docker here. So maybe if we go to the order service, yeah, it will basically, like, the container is outputting some logs of the published message, and it will basically show the total, the product ID, quantity is 6 because we just ordered 6 of these, right? Yeah, and so these logs can be quite helpful in debugging. Yeah, I think that's everything that I wanted to kind of show. I learned quite a bit with this project, and I want to add a few more things. But yeah, that's all I wanted to kind of share with you today. Right, thank you for listening.